Right, here's a relatively easy question, I think. This is question 2 on page 354. It says for each of these sets of graphs, do the following things. Alright, write down the equation of the red graph, so there's my red one there. And then I've got to do a transformation of the red graph and write down the equation of each of the black graphs. So all these black graphs are transformations of the original red graph. And then I've got to write down the transformation that produces each family of graphs. Okay, not a difficult thing. So look at the red one, 1 1, 2 2, 3 3, 4 4. So essentially the red one's going to be y equals x, straightforward. And this one here is going to be y equals x plus 1. So E is going to be y equals x plus 1. The next one up, which is D, y equals x plus 2. I don't think I want to write all these, it's very boring and easy. For C, there's the C graph, y equals x plus 3. Okay, I'm just sort of keep going, can't I? B, y equals x plus 4. And graph A passes through 0, 5, y equals x plus 5. Not difficult at all, is it? Working down the page now, look at graph G. It passes through 0, minus 1. So that's going to be y equals x minus 1. The G graph passes through 0, minus 2. So that's y equals x minus 2. The H graph passes through minus 3. Y equals x minus 3. You never get this in an exam, by the way. It's far too long-winded. Graph I, 0, minus 4. So y equals x minus 4. Similarly, J passes through the point 0, minus 5. So y equals x minus 5. Essentially, let's just do some general teaching on this one. Essentially, I have y equals some sort of function of x. Actually, it's y equals x. Very straightforward. I then had to take my original function and transform it by adding a or subtracting a. So obviously, if a is positive, it goes up. If a is negative, it goes down. So what happens is I have to transform the function y equals x using vector 0 a, and of course the a value could be either positive or negative. So for example, if I look at function a, I've got y equals x plus 5. There it is right there, passing through 0, 5. So the a value would have been 0, 5 for graph A. For graph B, y equals x plus 4. That would have been 0, 4. But therefore, the general transformation that produces this family of graphs is therefore a translation. Okay? Now, it's not asking me to write down the translation for each of these, but it's easily done. For y equals x minus 5, the translation, for example, would be 0, minus 5. The translation for y equals x minus 2, if I write it here, x minus 2, the translation would be 0, minus 2 as you drag the graph down 2 units. And this one over here for B, for example, is passes through 0, 4, so I go y equals x plus 4. Essentially the translation is 0 and 4 units up. Alright, very, very easy. So that's question 2 done. Now I've got this one to do as well. First, let's just identify the red graph. Well, that's the coordinate 1, 1. That's the coordinates 2, 4. I reckon we're playing with y equals x squared. Very easy. So let's look at graph B. Let's just list them here then. I've got B, I've got A, I've got C, and I've got D. Very straightforward. Let's do A first. So that's going to be y equals x, but it passes through 0, 4. I've lifted it up 4 units. That's going to be y equals x squared, plus 4. Graph B, I've lifted it 2 units up in the y direction, so y equals x squared plus 2. C has dropped 2 units in the negative y direction, y equals x squared minus 2. And the D graph is going to be x squared minus 4 because it passes through 0, minus 4. There it is, x squared minus 4. Write down the transformation that produces each family of graphs. Well, this is also a translation. Let's just write this in red here. So these are all translations of the function y equals x squared. Alright, very straightforward. Again, you can tell what the function is. So if, for example, that's the point 0, 2, I've gone from 0, 0 on the original y equals x squared to 0, 2 on the transformed y equals x squared plus 2. So e.g., let's just make a black and white example here, or red and white in this case. Y equals x squared plus 2. I've therefore used the vector 0, 2 to lift the graph 2 units in the y direction. Looking at this one here, 0 minus 2, so y equals x squared minus 2. I've transformed the original y equals x squared into y equals x squared minus 2 using vector 0, minus 2, and what I've done is just to drop the graph 2 units going down, so it's minus 2 going that direction. Alright, and that's all there is to it. So these are all translations lifting up and down the y-axis, up and down like a yo-yo, and that's really, really easy. And question 2 should have been the starter question really, because that was really easy compared to question 1, which was a nightmare. So I'm going to stop there and then prep question 3.